All right, hello. Let's do our 3.3 notes on function notation. First, there's some vocabulary. So what is function notation? So function notation is where you use f of x in place of y. And this is where the whole thing, so this f of x is sort of like the name of your function. And this x right here lets you know what variable is considered your input. And this entire thing is then going to be used later as sort of like an output. So whenever you see y equals, you can think of it as f of x equals, or if you see f of x equals, you can treat it as like a y equals in terms of your graphing calculator. So let's look at example 1. It says evaluate the function f of x equals negative 4x plus 7 when x equals 2 and x equals negative 2. So this is wanting you to basically take these x values and plug them in for every x that you see and then see what happens. So let's look at this first one. I'm going to write f of 2. So this is really asking what is the value of this function when I have an input of 2. And to figure that out, I'm going to write negative 4 times 2 plus 7. And then I could put that in the calculator and I get negative 1. So I'm going to say f of 2 equals negative 1. That is part of the function notation, though, is you need to make sure you have not just f of x, but in the solution, or when you evaluate it, make sure your function notation says f of, that's how you read it, and then whatever number is the input. This next one, I'm going to say f of negative 2 equals negative 4 times negative 2 plus 7. When I type that in the calculator, I get 15. So f of negative 2 is worth 15. If we go back to the nuggetizer video that we watched in class, these would be our inputs. So this would be saying, like, as I put in chicken, I got out chicken nuggets. F of negative 2 would mean when I use the nuggetizer and I plug in a cow, I got out the steak fingers. Okay. Example 2, let f of t be the outside temperature in degrees Fahrenheit, t hours after 6 a.m. This is idea. This is a big thing here. Hours after 6 a.m. So think about if it was 2 hours after 6 a.m., it's 8 a.m. Now it says explain the meaning of each statement. So f of 0. So this 0 means when t equals 0, which means 0 hours after 6 a.m. Well, 0 hours after 6 a.m. is just 6 a.m. So this one right here is saying at 6 a.m. the temperature is, if you look, it said the temperature is 58 degrees. So I can say 58 degrees Fahrenheit. At 6 a.m. the temperature is 58 degrees Fahrenheit. Part 2b is a little bit more challenging because there's this n here. So first of all, 6. This 6. What is 6 hours after 6 a.m.? What's 6 hours after 6 a.m.? That's 12 o'clock noon. So on this one, I can write at noon, the temperature is, now let's see what it says now. It shows that the temperature is n, oh that looks weird, n degrees Fahrenheit, which means we don't know the exact temperature here because they're using a variable and that's okay. But that's how we would explain this meaning. All right, now notice this last one here, we're comparing the two temperatures. We're comparing 3 hours after and 9 hours after. So 3 hours after 6 a.m., is going to be 9 a.m. So this is the temperature at 9 a.m. 9 hours after, well, that's going to be at 3 p.m. And we're talking about the temperatures here. So this is saying the temperature at 9 a.m. is less than the temperature at 3 p.m. And that's exactly what we're going to write here, is the temperature at 9 a.m. is less than or colder than the temperature at 3 p.m. Again, as always, if you need to pause this to copy things down, that's great, because sometimes I might be going a little faster than you are. All right, I'm going to skip the on your own. You can do those, but I'm just going to skip those for right now, and you can get a hold of me. I just want to make our notes a little faster. So let's go ahead and look at example 3 real quick. For h of x equals 2/3 x minus, find and evaluate the value of x for which h of x equals -7. The big thing here is they're giving me h of x equals -7. So that means everywhere I see h of x, I need to put -7. So that's going to go in here. So when it says find the value of x, I want to find x, which means I don't put in anything for x. So right down here, I'm going to put in the -7 equals 2/3 x minus 5. This is a common one students mess up on a quiz and test because they just want to plug in -7 for x. What this is saying, if my output is -7, what's my input? So let's solve this. I'm going to add 5 to both sides. I'm going to get -2 equals 2/3 x. I'm going to multiply both sides by my reciprocal, which is 3/2. And I'm going to get x equals -6. There we go. X equals -6. All right, example number 4. Graph f of x equals 2x plus 5. This is where you have two options. I can make an input-output table. I can say x and then f of x. And I need, I'm going to say for us, use the points -2, -1, 0, 1, and 2 right now. We need, I would say, at least 4 points, but 5 would be good. Because if you only use 3, you don't know which 2 of the 3 are the right ones, because any 2 points make a straight line. So you need 4 or more, so at least hopefully 3 of the 4 will be in a straight line. You'll know which one is the one that's incorrect. So you could do this by hand. You could plug in -2. So I could figure out, well, what is 2 times -2 plus 5? And that's going to be 1. And then I can put this in and get, oh, it's going to be 6. I mean, not 6. What's that going to be? It's going to be actually 3. And then I'm going to get 5, and then 7, and then 9. Like, I can fill those in. Or if you don't want to do them by hand, you could use your handy dandy calculator. Go to your y equals here and just type in 2x plus 5. Oh, helps if you can see what I'm doing here. 2x plus 5. And then I can hit second and then table. And then I can look at my table of values here. I can see that I have my 1, my 3, my 5, my 7, and my 9. So I can use my table of values from my calculator and then just transfer them over to my paper and my graph. So right now I'm going to make my graph. So I'm going to plot these as my ordered pairs. So these are treated as ordered pairs. You don't actually have to do what I'm doing here, but I can put these in parentheses. So -2, 1 goes here. Oh, helps if I, there we go. -1, 3, 0, 5, 1, 7, 2, 9. And what I need to do is I need to first make a table. Then I need to plot the points. Then I need to connect the points unless it's a discrete function. If it's discrete, individual points. And then the very last thing here is don't forget the arrows. Now this has to go the whole length of the entire graph. So I'm going to go here. It would help if, so this is easier for you with a ruler. If you're online, it could be a little tricky. So bear with me as I try to get my computer to do what I want it to. So notice I'm going the whole length of the graph, not just one little section, not just where my points are, but the whole length of the graph that I provided, and then I put arrows on the ends. All right, there is an on your own that you can do. Right here, there's number 4 and 5, and then you can do these graphs. I will recommend that when you do number 8, if you do number 8, you want to use multiples of the denominator. If you do that, you're not going to have to plot any fractions. So if you do your little t-chart here, multiples of the denominator would be like -8, -4, 0, 4, and 8. And that way, you will not have any fractions or decimals to graph. Now, if there's points that you put in your chart, you get in your chart that don't fit on the graph, fine, only plot the ones that fit. You can use the numbers -2, -1, 0, 1, and 2, but you might have some fractions to graph, which will be a little bit more challenging. So you can. Just know if you ever have numbers that are too big for your graph, just don't plot them. All right, only plot the ones that will fit on there. All right, let's do this last one here. So this graph shows the number of miles a helicopter is from its destination after X hours on its first flight. On its second flight, the helicopter travels 50 miles farther and increases its speed by 25 miles per hour. The function f of x equals 350 minus 125x represents the second flight, where f of x is the number of miles the helicopter is from its destination after X hours. Which flight takes less time? So there's a lot of stuff going on in here right now. And so if we look at this one, there's this graph here, you'll notice at 300 miles after 0 hours, and then this took 3 hours to get to 0. So it took 3 hours. So what I would think here is, if you want to know which one takes longer, so which one takes less time, we need to know how long it takes for the first one and the second one to get there. So just off the top of our head, just before we do any like real writing math equations, this first flight, you'll notice the first flight takes 3 hours. So I might just write this. First flight takes 3 hours. And we get that from the graph, which is super easy to figure out. Now, notice when it took 3 hours, notice my distance here is 0. So what does this mean? My first flight would be, I wanted to figure out what, we wanted to figure out what is x when f of x is 0, because f of x represents our distance. And so from the graph here, it told me 3 hours. So let's look at the second flight. So the second flight here, if I plug this in, that means I want to figure out when is it that I get 0, the distance is 0, with the equation 350 minus 125x. Right. So I'm going to plug that 0 in for there. Let's go ahead and solve this. I'm going to get -300. Actually, I want to move the x so we can have positive x's maybe. I'm going to have 125x equals 350. So when I divide, I get x equals 2.8 hours. So this is the second flight. So notice from the first flight, the graph told me that when f of x is 0, my x is 3, so it takes 3 hours. The second flight through the equation, we got that when f of x is 0, the flight takes 2.8 hours. So which flight takes less time? And then explain. My answer here would be the second flight takes less time because the first flight took 3 hours and the second took 2.8 hours. Helps if I can spell the word second. The second took 2.8 hours. And there is an on your own here that you could do. And you can ask me for help with that if you want. But for our notes, we're going to be done today. So good luck, and we'll see you here next time.